Hello and welcome to another video regarding Millman's theorem, right? So we have this theorem, which is very important when it comes to what a circuit diagram, especially if we are trying to find the current passing through a load resistor in the circuit diagram. This theorem can be very useful in that regard. How do we use this Millman's theorem? This theorem is similar to all other theorems regarding circuit diagrams. Right? The idea is that you want to simplify the circuit diagram so that you have a simple circuit, right? And here our equivalent circuit here is going to what? Equivalent voltage instead of equivalent resistance. That will be our equivalent circuit for the linear active circuit. Then after that, you connect your load resistor, then you can get the current, right? Passing through the load resistor. And you can only apply this Millman's theorem when it comes to a specific kind of circuit diagram, right? So if you look at the first branch here, I have V1, which is a voltage, and C is what? R1. Then the next one, V2, which is a voltage, and C is what? R2. Another voltage, and C is what? R2. And all these are connected in parallel, right? So you see all these branches are in parallel. All right. So when you have such a circuit diagram, then you can apply Millman's theorem, right? And then you have your load here, right? And Millman's theorem is based on what? The application of source transformation, right? So here you think about source transformation, and then based on that, we are able to get the parameters of our equivalent circuit, meaning equivalent voltage and equivalent resistance. Now, let's say we have this, we want to do source transformation, we want to perform source transformation on this circuit diagram. What that means, you can see the voltage is instead what? V1 is instead what? R1, meaning I can convert that to what? A current being in parallel with what? A resistor, right? So that means I'll have R1 is in parallel with what? R1. So the second branch, V2, is instead what? R2. I can convert that to what? Current I2 in parallel with what? R3. And the same for what? R3 up to what? The nth resistor, which you also want IN in parallel with what? Rn. So after this, you can see clearly that all the resistors here, they are going to be what? In series. In parallel, right? Oops. Right. All these are going to be in parallel. So R1 will be parallel with R2, then R3 after the nth resistance. Then you can get the equivalent resistance using the formula for parallel connection of what? Resistance. That will be 1 over equivalent resistance equals to 1 over R1 plus 1 over R2 plus 1 over R3 up to the nth resistor being 1 over Rn. Then here, when it comes to the equivalent current, it's going to be the algebraic sum of the current, right? After the source transformation. Here, again, if you look at here, all the currents are going to also be in parallel. So you do the algebraic sum. So when the current direction is going up, that means it's positive. If the current direction is going down, we indicate that as negative. So you can see here, because I have the polarities here, minus to plus, right? The positive terminal is above the negative terminal. Then that means the current will be going up, right? The same for all of them. So they are all going up. So the algebraic sum the R1 plus R3 up to the nth current. Then I can calculate the equivalent voltage. Now equivalent current times equivalent resistance. That will give me this, right? Now I have my equivalent circuit diagram, voltage, equivalent voltage, and series what equivalent resistance. Then I can get the load current IL. That will be what? The equivalent voltage over this and this are in series, right? So we have this plus what? RL. So that will give me the current pattern to this. So this is how you use Millman theorem, and you can only use it for specific kind of circuit diagram. So before you use this, you make sure that you look at the circuit diagram. If it resembles something of this nature, then you can use this theorem, right, to find the current passing through the load resistor in the circuit diagram. If it's your first time of watching video from this channel, make sure you subscribe. And I will bring in a lot of circuit diagram trying to solve them. So make sure that you subscribe to this YouTube channel. See you in the next video. Bye-bye.